Question. There are 3 coins. One is a two-headed coin having head on both faces. Another is a biased coin that comes up heads 75% of the time, and third is an unbiased coin. One of the 3 coins is chosen at random and tossed. It shows head. What is the probability that it was the two-headed coin? Solution. In this question, we have 3 distinct coins, one of which is two-headed, another is biased, and third is unbiased. Let E1 be the event that the chosen coin is two-headed. E2 be the event that the coin is biased, and E3 be the event that the coin is unbiased. Here, E1, E2 and E3 are mutually exclusive and exhaustive events. Since one of the 3 coins is chosen at random, so each of them has a same chance of being selected. Therefore, probability of E1 is equal to probability of E2 is equal to probability of E3 is equal to 1 by 3. Mark this equation as 1. Let A be the event that the chosen coin shows head. We want to find the probability that the chosen coin was the two-headed coin when it is given that the coin shows head. That is, we want to find the probability of E1 given A. For this, we will use a very significant theorem called the Bayes theorem. By using Bayes theorem, we get probability of E1 given A is equal to probability of E1 into probability of A given E1 upon probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2 plus probability of E3 into probability of A given E3. Mark this equation as 2. To find the required probability, firstly, we will find probability of A given E1, probability of A given E2, and probability of A given E3. Probability of A given E1 is equal to probability that the coin shows head when it is a two-headed coin. But if we toss the two-headed coin, the coin will always show head, as there is no other option. So, probability of A given E1 is equal to 1. Mark this equation as 3. It is given that on a biased coin, heads comes up 75% of the time. Therefore, probability of A given E2, which is equal to probability that the coin shows head when it is a biased coin, is equal to 75 by 100, which implies probability of A given E2 is equal to 3 by 4. Mark this equation as 4. And probability of A given E3 is equal to probability that the coin shows head when it is an unbiased coin. Since in case of an unbiased coin, the probability of head is same as the probability of tail. So, probability of a given E3 is equal to 1 by 2. Mark this equation as 5. By substituting the values of all probabilities from equations 1, 3, 4 and 5 in equation 2, we get probability of E1 given A is equal to 1 by 3 into 1 upon 1 by 3 into 1 plus 1 by 3 into 3 by 4 plus 1 by 3 into 1 by 2. By taking 1 by 3 common from the denominator, we get which is equal to 1 upon 4 plus 3 plus 2 by 4, which is equal to 1 into 4 by 9 is equal to 4 by 9. Hence, the required probability is 4 by 9.